morning, students. Today we will see the elasticity. We will start this new chapter, elasticity. The force applied to a body can produce a change in the shape or size or both in shape and size of the body. Such a change is called the deformation. By applying suitable force, our bodies can be more or less deformed. Following are the simplest cases of the body, the simplest cases of the deformation. The first is change in the length, change in the volume but no change in the shape, change in the shape but no change in volume. For changing the shape and size of the body, there requires some force. That force is called the deforming force. So that the deforming force is defined as the force which produces deformation in the body. Elasticity is the property possessed by the material body by virtue of which it regains its original condition when applied deforming force are removed. Bodies which can recover completely their original condition on the removal of the deforming force are said to be perfectly elastic. On the other hand, bodies which do not show any tendency to recover their original conditions are said to be plastic. The to recover and also rubber cord. This is the example of elastic body. Rubber cord metal like steel, metal like steel, steel, copper, silver, gold, copper, silver, gold are the examples of elasticity. Within the elastic limit are the examples of elastic bodies. Now, the examples of plastic bodies are clay and wax and plasticine, plasticine are the examples of plastic bodies. Plastics. The internal restoring force, as body regains its original condition, and this property of body regaining its original condition or original position is called elasticity. Means there is a internal force, and the internal force per unit area, the internal force per unit area is called stress. As the body regains its original condition, that is the property of the material which regains its original condition, and this property of body is called the elasticity. As the body regains its original position, means there is some internal force, and that internal force per unit area is called the stress. Means the force per unit area is called the stress. Now, the unit of stress is Newton per meter square. The unit of stress is Newton per meter square, and the this is the unit of stress in MPS system, and the unit of stress in CGS system is the unit of stress in CGS system is dyne per centimeter square. There are three types of stress. There are three types of stress. Number one is the tensile stress. Here I write stress, and there are three types of stress. First is tensile stress, or is called longitudinal stress. Second, volume stress, and third is shearing stress. Shearing stress. Similarly, the change in the dimensions per unit original dimensions is called strain. The definition of strain is the change in the dimensions, the change in the dimensions per unit per unit original dimension per unit original dimensions is called strain. Is called strain. As strain is a ratio of similar quantities. As strain is a ratio of similar quantities, therefore it does not have any unit. It is a pure number. Similarly, as a stress, there are three types of strains. That strains are the I write that strains here. Strain first, the tensile strain. Tensile strain, that is longitudinal strain. Second one is the volume strain. Volume strain, and third one is shearing strain. Shearing strain. Shearing strain. According to Hooke's law, now here up to here we are seeing what is the elasticity and the definition of deforming force. If we apply a force to a material or a body, by virtue of which the body gets deformed, that force is called the deforming force. As we are applying the force to a body, that body deforms, but body again tries to regain its original position, and this property of body is called the elasticity. Then, as the body is regaining its original position, means there is some internal force internal restoring force. That internal restoring force per unit area is called the stress. And again the next quantity, that is strain. A strain is nothing but the uh, change in the dimensions per unit original dimensions is called the strain. As the strain is the ratio of the similar quantities, so the strain does not have any unit, but stress having the unit Newton per meter square in CGS system, and in MK system, its unit of stress is Newton per meter square, and in CGS system it is strain. The unit of stress in CGS system is dyne per centimeter square. According to Hooke's law, within the elastic limit, the stress is directly proportional to the strain. That is called the modulus of elasticity. Modulus of elasticity. And it is nothing but given by stress upon strain. This means that there is the stress and strain are directly proportional to each other. Now, the unit of modulus of elasticity is in MK system. Its unit is Newton per meter square, and in CGS system, its unit is dyne per centimeter square. This is the Hooke's law. Now, the modulus of elasticity. I will see the modulus of elasticity. Of elasticity. Modulus of elasticity. This is the modulus of elasticity is a material property which shows the stiffness of the material, and it is one of the most important property of the material. By the if mechanically the body is if suppose there is some deformation mechanically deformation puts energy into the body, means it stores. When there is a deformation, means the body stores energy into it, and this energy stored elastically or dissipated plastically. The way a material stores this energy is summarized in stress and stress curves. Stress is defined as stress is defined as force per unit area and strain as elongation or contraction per unit length. Strain as elongation or contraction per unit length. This is the definition of the stress and strain. Now, when a material deforms elastically, the amount of the deformation likewise depends on the size of the material, but the strain for a given stress is always the same, and the two are related by the Hooke's law. That is, stress is directly proportional to the strain. There are three types of the modulus of elasticity: for solid, corresponding to three types of the strain and stress. There are three types of modulus of elasticity corresponding to three types of stress and strains. The first type is Young's modulus. This Young's modulus can very easily Young's modulus within the elastic limit, it is the ratio of longitudinal stress to longitudinal strain. Young's modulus is denoted by Y, and it is nothing but the ratio longitudinal stress upon longitudinal strain. This can be understood by in the figure we have taken this is a wire rope, and at the free end of this wire rope we hang a weight here. Due to this weight, this wire get elongated and its shape gets deformed like this as shown in the figure. Now we can calculate the Young's modulus of this wire. Here this is the circular part. Here the strain, as here the force applied, force per unit area, and this is the elongation per change in the length. Therefore we can calculate this. This is the original length of the wire, and after elongation this wire get elongated up to this level, and this is the length of the wire after elongation. Now let us consider a metal wire of original length L and radius R is suspended from a rigid support. Let mass M is attached to free end of the wire such that its length increased by L as shown in the figure. This is the length which is increased length of the wire because of this weight which is hanging here to the free end. Now we will calculate its Young's modulus. As there is the change in the, first of all we will calculate the longitudinal strain. Therefore longitudinal strain equals to the longitudinal strain equal to the change in the length upon original length. Change in length upon original length. That is small l divided by capital L. With this we are getting the strain of this wire. Now we will calculate the stress of this wire. Stress can be is longitudinal stress. Longitudinal stress, that is equals to applied force upon area of cross section upon area of cross section. Area of cross section. This can be written as the force applied is mass of the wire into the acceleration due to the gravity, with mg gives us the force applied on this wire divided by area of the cross section. At this circular part we have applied the force, and this circular part is nothing but the circle, and area of it is given by pi r square. Therefore mg upon pi r square gives the longitudinal stress of the wire. Now lastly we calculate, now by the definition we calculate the Young's modulus of the wire. Therefore Young's modulus of the wire can be calculated y equal to longitudinal stress upon longitudinal strain. This can be written as y equal to mg upon pi r square divided by L upon L. And lastly, we can write this formula. It is equals to mgl mg into capital L upon pi r square small l. With this formula, we will calculate the Young's modulus of the wire. With this, we have finished the first point of the elasticity. In next period, we will see the bulk modulus, and then thereafter we will see the modulus of rigidity. I think this is the enough for this period.